Okay, so in this video, what I'm going to do is show you how to work some probability applications using the normal distribution. We're going to do this rather than using tables. I'm going to show you how to use the TI graphing calculator's normal CDF function to do this. All right, so let's give a look. I got an example here with Facebook time. It says the average amount of time a person age 16 to 22 spends on Facebook per month is a normally distributed with a mean of 7 hours and a standard deviation of 1.5 hours. Okay, so that means every time we come to a bell curve that, we're going to be labeling the mean 7 and the standard deviation. I like to put the standard deviation up top here so it's out of my way, 1.5. All right, so it says, what is the probability in letter A that the person spends between 5 and 8 hours? All right, so from a shading standpoint, if there's a number 7 in the middle, 5 is over here. Remember, 5 is a raw score. And, 8 we'll put over here. And, this is not being drawn to scale. This is just drawn so that, we can see a picture and get an idea of where the probability region lives. So there is my shaded region under the bell curve. I'm shading the region from between 5 and 8. All right, so from a probability standpoint. All right, so this is the probability that x is in between 5 and 8. All right, so I'll write that like this. I'll put the x in the middle. And I'll sandwich the 5 and 8 between less than signs. This is the probability x is in between 5 and 8. Now, to be honest, theoretically, hitting exactly 5 hours, we wouldn't even know that. So, I put less than or equals here. But if I put less than or equals or just strictly less than, remember, the probability of hitting 5 hours or the probability of hitting 8 hours exactly is 0. So it doesn't make a difference whether we put that or not. Now, if we want to be really strict about this, between 5 and 8 hours, then I think we should just use strict less than symbols. All right, so now what about your calculator statement? All right, well, remember the normal CDF operation. What I'll do is I'll abbreviate it a little bit. Normal CDF, you technically write out the word normal and then CDF. I'll write NCDF, just so I could fit it in here. My space is a little limited. The syntax for normal CDF is the lower bound of the shade followed by the upper bound of the shade. So those first two inputs of normal CDF, what they do is they describe the shaded region. Then the next two inputs of normal CDF describe the shape of the distribution, which is a mean of 7 and a standard deviation of 1.5. Now, depending on your calculator, depends on how this will appear. They'll all appear the same way eventually. But if I want to type this, you go second vars, and it's option number 2 in your calculator. We never use normal PDF, not for us. We're going to use normal CDF option 2. Now, I have a newer version of the calculator. So what it does is it picks my brain and says, what's the lower bound of the shade, the upper bound, and then the mean and standard deviation. Now, if you have an old TI84, you may not have this information like this because you may not have the updated operating system, which is fine. Yours will appear as I wrote it in the calculator statement, in the example there. So let me put these values in. So the lower was 5, the upper was 8. The mean is 7, and the standard deviation is 1.5. So when I hit paste, this is how it would look if you had an old version of the calculator. You wouldn't have seen that prior menu. The new menu is nice, and if you want the new menu, you could come visit me during office hours, and I could share the updated operating system with you. All right, so let it crunch it. All right, so that's 0.6563 approximately. So 0.6563. Now, as a percentage, that's about 66%, right? So, rounding is rounding, and we have to be careful with rounding. But my math lab, when you're doing your My Math Lab homework, they always tell you what to round to. So you never really have to worry about that. All right, not too bad. Let's give a look at letter B. One person selected. What's the probability the person spends more than 4 hours? All right, so remember, once again, the mean, 7 hours. Standard deviation, 1.5 hours. All right, 4 is over here somewhere. It's a raw score, 4. And it says more than 4 hours. So the probability this randomly selected guy is more than 4 hours. All right, so we'll be shading to the right of 4. Remember, theoretically, that shades to forever, which is infinity. Now remember, your calculator doesn't understand infinity. Your calculator uses E99 for infinity. To be honest with you, I don't like using E99. I just pick some ridiculous number like, 100 out there. If the average guy's spending 7, nobody's spending 100. But, we could talk about the idea of infinity at some other video. But the calculator statement would be normal CDF, lower bound of shade, which is 4, the upper bound of shade, which is infinity, so I'll write E99, and then the mean, and then the standard deviation. So remember, what the calculator is doing is it's converting to a z-score, then looking the z-score up in the z-score table for us so that we don't have to do it. It's saving us some time. All right, so once you have this statement in here, it's virtually there, with the 7 and the 1.5 in there. So if you hit second enter, it just brings up the last thing you typed. And then what you can do is just go in there and modify it, which is kind of nice. So I'm just going to go here and change the 5 to a 4. And I need to change that 8 to infinity. Now, infinity, remember, is E99, and how you type that is you have to activate the scientific notation for 10 to, though, which is, the E, and it's actually above the comma right here. It says EE if you see it. So you go second, comma, oops, sorry about that, second, comma, and it puts the E in there. Now I got to type 2 9s. So it says, shade from 4 to infinity under a normal distribution whose mean is 7 and standard deviation is 1.5. All right, 0.9772. And that's about 97.7%, which, by the way, that makes a lot of sense, because if you think about it, the region, over here, this chunk right here, that's half the picture, right? Shading that way forever. That's 50% of the picture right there. This is shading 50% and then some, as you can see. And I'm not even doing the question justice. This 4 right here probably should be drawn a little bit to the left, as you can see. But, again, it's just a visual, don't forget. All right, so there's our probability. So let's give a look at letter C. What is the percentile rank of an individual who spends 6.25 hours? Okay, same deal. The mean, 7, standard deviation, 1.5. Now, someone that scores 6.25, all right, they're over here somewhere. They're spending 6.25 hours per month on Facebook. Now, remember what percentile rank means. Percentile rank is the percent of people that you beat or tie. Now, a guy that's spending this much hours on Facebook is, beating or tying these guys. In other words, spending more time than them. So really, this question in disguise is saying, hey, what's the area? What's the probability some guy is spending less than 6.25 hours? So the probability X is less than 6.25. Now, down here, on the left, this is negative E99. I just like to use 0. Technically, don't forget, it's negative infinity. But what does negative infinity mean? We're talking about time on Facebook. You can't spend negative time on Facebook. So to me, that number is 0. So my calculator statement, normal CDF, lower bound of shade, I'm just going to use 0. If you want to use negative E99, go ahead. We'll get the same answer. Upper bound of shade, 6.25. The mean is 7. And standard deviation is 1.5. All right, so let's go to our calculator. Again, second enter. I'm just using the second enter option because it's just faster. If you want to go back to the menu again, you could go back to the menu and go second, bars, and go ahead and, retype everything. But once you have that expression typed in once, I think all you got to do is just really modify the prior one, especially when you're doing a bunch of questions in a row, with the same normal distribution, with the same mean and same standard deviation. All right, so I'm going to use 0 and 6.25. And the same mean and standard deviation. All right, 0.3085. Which as a percent, that's 30.85 as a percentage. And remember, percentile rank we round that. So that's going to be the 31st percentile. Typically, we round percentiles to the nearest percentage. All right, let's give a look at letter D. Letter D. If we study 200 random Facebook users, how many? All right, well, you see I spelled how wrong there, but how many will spend more than 4 hours on Facebook? All right, well, that's not a probability question. That's talking about how many of these 200. Well, you know what? If you go back to letter B, you could notice that we already found the probability that someone spends more than 4 hours. So right now, we already got that number. That's this thing right here. 97.7% spend more than 4 hours. So they don't want to know the percentage, they want to know how many. So that would be this 0.9772 multiplied by the 200 users. You know, how many of these 200 users? All right, so let's see what we get here for this. 0.9772 of the 200 users. Obviously, it's almost all of them. It's 195.44. Let's just call that about 195 of these users. All right, so pretty much all these applications are the same, as you can see. They usually involve, you know, shade in the middle, shade to the right, shade to the left. These probability applications really are kind of the same. Once in a while, you get something like letter D where it picks your brain on something different, asking you a question of how many, which you just have to be careful, pay attention to things like that. When it says, what's the probability versus how many? Some questions, you know, ask for a probability. Like this question did in letter A. If you notice, it asked for a probability. I wrote it as a percentage. Sometimes my math lab does that. Sometimes they don't. You just have to pay attention to the directions and what they're looking for. And of course, pay attention to what they ask you to round to. All right. So if you have any questions, feel free to shoot me an email. Thanks for watching.